Hi, I'm Steve Sobek, and this is the first in a series of video lessons on how to use the TI-84 graphing calculator. And in this first lesson, we're going to just cover some of the basic features of the calculator. For example, how to evaluate expressions like what we see here. Here's the first expression. If we want to evaluate this on the calculator, we would first hit the 5 key. And then to square it, the x squared key is right over here. Hit 5 squared plus 2, and then here's your left parenthesis. Notice as I hit the buttons on the calculator that you can see that they turn red, so it makes it a little bit easier for you to know what I'm hitting. And within the parentheses we have a 3 plus 7, and hit the enter key, and we get 45. And certainly we can confirm that if we were to evaluate it ourselves. We know enough to do the parentheses first. 3 plus 7 is 10. And then the exponents, 5 squared is 25. And then the multiplication has priority over the addition. So take 2 times the 10, 20, and 25 plus the 20 gives us the 45. Many students don't trust that the calculator will evaluate the expression using the correct order of operations. That's why you see many students type in 3 plus 7, enter, they get 10. And then multiply it by 2, 20, and then add 5 squared. And they get the right answer, but it demonstrates, it takes longer, and it demonstrates that their lack of confidence in the calculator. You can trust that the TI-84 will execute the operations according to the correct order of operations. Not all calculators do. This one does. Here's example number 2. We have 20 plus 6 in the numerator. We know that the fraction bar is a grouping symbol. We know that if we were evaluating this ourselves, that we would do what's on top first, evaluate the whole numerator to get 26, and then divide the result by 2, giving us the correct answer of 13. On the calculator, you're going to have to enclose that numerator in parentheses. So left parenthesis, 20 plus 6, close it, and then the fraction bar division is right here by 2, and indeed we get 13. Without those parentheses, it will only divide the 6 by 2, giving you 3. 20 plus 3 is 23. So that's a common mistake. We've learned from this example that sometimes we need to introduce parentheses even though we don't see any in the problem. Okay, hopefully you've learned that. Change this into a fraction. Change decimal into a fraction. Let's type in 0.375. And then change to fraction is in the math menu. Here's the math button. Click that. Number 1 is change to a fraction. To choose things from this menu, you can either hit the number adjacent to each of these features, or use your up and down arrow keys followed by the enter key. I like to just hit the numbers. Okay, this is number 1, and that pops 0.375. Change it into a fraction, hit enter, and we get the fractional equivalent, 3/8. Also, the fraction that it gives is reduced. So that's kind of neat. So you could actually use that to reduce fractions. You could start with a fraction, like here's an unreduced fraction, and we can use the same feature to reduce fractions. So let's go ahead and type in 130 divided by 182. And then math, number 1, change to fraction, hit enter, and we get 5/7. All right, I also want to mention that sometimes after you've hit the enter key, you realize that you've made a mistake. You typed it wrong, and you're thinking, oh, I'm going to have to type it all over again. Maybe it's a longer expression, like maybe the first expression that we did way up here, or much longer than that. You don't. You can get back expressions that you've typed before. If you hit second enter, it gives you the most recent expression that you had typed, and If you hit second enter again, it gives you the one before that. And if we continue this process, we can get back to that problem that we had back at the beginning. Here it is. We didn't have to retype it. And suppose that that 2 right here was supposed to be an 8. Well, now notice that we have a blinking cursor. We are in edit mode. We could just hit our left arrow key and toggle over here. And we're automatically in overtype mode. So if we just hit the 8 button right now, it replaces the 2. It overtypes an 8 over top of that 2. And then you could hit enter and it reevaluates the expression with the correct values. All right. Also, another point for editing. Let's bring that expression up once more, second enter. And suppose that we want a 34 here instead of a 3. Well, overtype mode's not going to cut it. We want to insert a 4 between the plus sign and the 3. So use your left arrow key to get your blinking cursor over top of the plus sign, and then hit second. Notice INS means insert, right above the delete key, insert, and then we could type in a 4, and the plus sign did not replace the plus sign. It was inserted prior to the plus sign. Also, so suppose you hit the 4 a couple too many times. We also want to show you how to delete characters. Let's move your cursor over top of one of these 4s that you wish to delete. And as you can expect, DEL is your delete button. Just hit delete and it wipes it out. So I hit my delete 3 times and those 3 extraneous 4s are now history. So now we can hit enter and evaluate the expression. Okay, some neat features. You could also, since we're mentioning second entry, the entry to bring back the recent expression that we evaluated, we could also bring back the most recent answer. Okay, every time you hit the enter key and evaluate an expression, the answer is stored in a variable called ANS. And here it is, ANS, that blue text right above the negative sign. So if you just hit second ANS, you could use that plus, let's say plus 1. And that takes the previous answer, 353, plus 1, which would be 354, and just as we expected. Okay, so there's a few things that will come in handy. Okay, if you want to clear the screen, then the clear button will clear the screen. Unless you were just, typing an expression in, then it will clear. The first time you click clear, it clears the line that you're currently on, and then the second time you hit clear, it clears everything from the screen. So here's some more problems. 2 raised to the 3rd power. Type in a 2, and raised to the 3rd power there's no buttons for that, but if we go into the math menu, here's the math button. Notice that number 3 will cube something for you. So choose number 3, and it put in 2 cubed, and hit the enter key, and 2 times 2 times 2, of course, is 8. So we get 8 just as we expected. 2 raised to the 6th power, well, we don't have any buttons, or we don't, even in the math menu, we don't see raised to the 6th power, so we're going to have to do something a little bit different here. Let's type in 2, and this little TP, or caret, whatever you want to call it, right above the division sign, below the clear, that is your exponentiation button. That's your raise to the. So you click that one time, and now we could type in the exponent, 6. Now we have a little bit of a problem that the cursor is still up here in the exponent. If we type a plus sign now, it's going to be part of the exponent. So we have to hit the right arrow key to move out of the exponent. Now we're down below here. Now we can hit the plus sign and then type in a 10 and hit enter, and we get what we expected. 2 to the 6th power, of course, is 64, and 64 plus 10 is 74. All right, 2 to the 40th power. You might say, well, we just did one like that. Well, yeah, something strange is going to happen when we do this. All right, so hang on to your chairs. Don't be afraid. 2 raised to the 40th power, and now we expect a very big answer. I mean, way bigger than 74. All right, 2 to the 6th power was 64. All right, so we hit enter, and we, whoa, what is this? 1 point something? I expected a real big number. This is very confusing, and it may be to you, except after you listen to this video, you'll understand what's going on. What's happening here is the TI-84, for very large numbers, will express them in scientific notation. What's happening here is the calculator is expressing the answer. It does this for very large numbers. It expresses those answers in scientific notation, or its own form of scientific notation. We see here a capital E, not to be confused with a lowercase constant e. But this capital E means times 10 raised to the, and here we have 12th power. So that would be tantamount to 1.0995 times 10 raised to the 12th power. Which of course would move that decimal. If you take this decimal point and move 12 bunny hops to the right, you've got a very, very big number, just as we expected. All right, so don't be alarmed when you see a capital E appear in your answer. That's scientific notation. Very large numbers or very, very small numbers, that E is going to pop up, and now you know what it means. Okay, let's clear the screen. And let's move on. We got the square root of 49. All right, the square root is right above this x squared button. We see square root. So we would hit second square root and type in 49. Okay, of course, what positive number times by itself is equal to 49? That would be 7. So when we hit enter, we get to 7 as we expected. The cube root of 125, or the third root of 125, or it's asking what number, positive or negative, what number times by itself 3 times will give you what's inside, what's the radicand, 125. Well, that would be 5, because 5 times 5 times 5 is 125. 5 times 5 is 25, and 25 times 5 is 125. So we expect this answer to be 5, and let's go ahead and write that down. And on the calculator, where's the cube root? You may have seen it. It was in the math menu. Let's hit the math button, and there's the third root right here, number 4. And we could type in the 125 and hit enter, and we get 5 as expected. The fifth root, ooh, that was not in the math menu. Neither is the 6th root or the 7th root, okay? Now, of course, this is an easy, we know the answer. I deliberately choose easy problems when you're testing out new features of the calculator. It's nice to use very easy problems that you can figure out yourself, so you know whether you're using the calculator properly. What number times by itself uses a factor of 5 times will give you 32. Okay, well that would be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right, so let's go ahead and write that down. And how would we do that on the calculator? It's going to look a little funny at first, but we're going to start by hitting a 5. And you're thinking, well, that doesn't look anything like an index of a radical. And it doesn't now, but it will. And then we'll hit the math button, and number 5 is the xth root. As soon as we choose number 5 by hitting the 5 key, that 5 that was looking like a coefficient got popped up in there and now is the index. And it's now ready for the radicand, 32. And hit enter, and we get 2 as expected. Second quit. Okay, what happens if you inadvertently, or what if your little brother or sister comes in the room and, you know, maybe they hit the stat button and one of these buttons that you didn't expect, and you're thinking, oh no, what do I do now? How do I get back to the home screen? You've ruined everything. Don't be too upset with them. It's very easy to get back to the home screen. Second, quit is your ticket. Quit is right above the mode button. Hit second, quit, and you're right back to where you were before. Here's the home screen. Let's hit the clear button as we move on. All right, you may or may not have covered logarithms yet, but for those of you who have, this would be an Algebra 2 topic. Suppose we wanted to figure out the log base 10 of 1,000. Now remember, this represents the exponent, which when 10 is raised to that power, it will give you 1,000. We know, of course, that that would be a 3, because 10 raised to the 3 power would give you 1,000. All right. Now, how to make the calculator evaluate that? Well, here's the log button right here. We notice that there is no base indicated on this button, but if we hit that and type in 1,000, that is base 10. It doesn't show the base. Okay, bases are usually written here, but just like your teacher, whenever he uses base 10, he omits the 10, because that's when you omit the base, it means base 10. And hit the enter key, and we get the 3. All right. Now that's log base 10. There's one other log button on the calculator. This is log base E. All right. Now E, I don't know if you remember, here's the constant E above the division key. Okay, that's the constant E. We have log base 10 and log base E. We don't see a log base 2 or log base 3 or log base 4. How do we do that? Well, we don't need the calculator for this problem, because we know this is asking 2 raised to what power is going to work out to a 64. And we've already done a problem previously. Remember, we evaluated 2 raised to the 6th power, and then we added 10 to it. 2 to the 6th power is 64, and so that is equal to 6. On the calculator, there's a couple ways you could knock that off. If you go to your math menu and hit the down arrow key, I have to get pretty low here. Oops, went too far. All right, I could go up to. Here's the log base right here. Hit the enter key to accept that. And you could type in any base that you want. We want a 2, and then we have to get out of the base. We don't want to hit a 6 now, because it'll show a 26 base. Hit the right arrow key to get out of the base, and move inside the parentheses for the 64. And then we can hit the, you could hit the right arrow key if you had more to type, but that's all we have. We hit the enter, and we get 6 as expected. Okay. Now, you might say you have to dig pretty deep to find that log base option. You don't need to use that. Remember that any of these problems like this, whether it's base 2, base 3, base 7, can be expressed in terms of base 10. So that's the same thing as the log base 10 of 64, close the parenthesis, divided by the log base 10 of 2, close the parenthesis, and we still get the same answer of 6. All right, so now, of course, that's for those who have covered logarithms. They know that. All right, if you haven't covered that yet, don't feel badly that you don't know that. All right. Pi 7 squared. All right. Pi is located right above this TP, this exponent key here. See it in blue? So we have to hit the shift button. The second button is like a shift. Hit second. Oh, no, you don't have to keep it down. Don't keep it down. Just hit it and let go. And then go over here and hit this button, and there's your pi. Okay, 3.141592654. And then we can hit 7 squared, be right here, and then hit the enter key, giving us the answer. Okay. Notice that I'm using implicit multiplication. You know, I could have used the multiplication key, but it's not necessary. If I want If I wanted to take 5 times 6, I could explicitly use a multiplication symbol. The asterisk is your multiplication symbol. But if in the absence, if we have 5 parentheses 6, in the absence of an operator, multiplication is assumed. That will still give you the same answer, 30. Likewise, if you put parentheses around the 5 or parentheses around both of them. All right. But of course, if you put a 5 and a 6 beside each other, that's not interpreted 5 times 6. That's the number 56. If you had a 5x, okay, a variable, or 5 pi, a constant, then implicit multiplication would be in force. All right, let's move on. All right, here we have negative 8 times negative 2. We know that a negative times a negative is a positive, in this case positive 16. The reason I put this up here is because sometimes students have trouble with problems involving negative signs, because there's a temptation to use the subtraction key. But we actually have a separate key for negative signs, and that's down here below the 3. And so we would type that first, negative 3, excuse me, back up, negative 8, and then in parentheses, a negative 2, and hit enter, and we get the positive 16. Now, the subtraction key looks just like a negative sign, and so let me bring that expression up again just to show you what would happen if I replace this negative sign in front of the 2 with a subtraction symbol. Sure looks like negative 2. I mean, you know, in class I write my negative sign just like that, so it certainly looks right. You can see how students can be deceived. But when I hit the enter key, I get an error syntax. When you get an error, you could either quit, or you could choose number 2 to go to where the problem is. And I'm going to choose number 2. And it says the problem is right here. And if you replace that with a negative sign and hit enter, it will properly evaluate that expression. So the moral of the story, be careful to always use this button down here for your negation. Do not use the subtraction key, despite how tempting it is because of its similarity looks. Okay, the sign of 90 degrees. All right, now we know the sign of 90 degrees is positive 1. Get ready to be shocked. I'm going to type in sign of 90 and hit enter, and oh, it doesn't say 1. Some people might be thinking, wow, this calculator is not very accurate. I mean, that's pretty close to 1, but it ought to do better than that. No, what's happening here, remember that angles can be measured in degrees and in radians, and your calculator is automatically in the radian mode. And we even some of the newer versions of the TI-84, the TI-84 has undergone several changes, and if you have the version like mine that has the word radian up here, that clues you in that you're not in degree mode, and it's going to interpret that not as 90 degrees but as 90 radians. If you want to evaluate the sign of 90 degrees, we have to hit the mode button, and right here we could see the fourth line down. We need to change this to degrees. So with your arrow keys, go down and then hit the right arrow to highlight degree, hit enter to change that, and then second quit to get back to the home screen. And now when we type in the sign, I could just hit second enter, the sign of 90 degrees, it'll reevaluate that in degree mode. We can see degrees right up here, and it will give us 1 as we expected. Right, in radian mode, 90 degrees would be pi over 2. So if we go back in here and change back into radian mode and type in the sign in parentheses, of pi, which is, we showed you where that was, divided by 2, and hit enter, we would get 1, just like we got the sign of 90 degrees is 1. Okay, All right, let's move on. All right, suppose we wanted to convert 100 degrees Celsius into its Fahrenheit equivalent. Well, here's the formula for changing Celsius to Fahrenheit, F equal 9/5 C plus 32. If you just had one problem to do, it would be no big deal to, in parentheses, type in 9/5 times, what did we say, 100? 100 plus 32. By the way, you should know that 100 degrees Celsius that's the boiling point, the same as 212 in Fahrenheit. Hit the enter key and we get 212 as we expected. And that's not a big deal if you just have one conversion to do. If you just had two conversions to do, that wouldn't be too much of a big deal. You might just say to yourself, well, I'm just going to use, Mr. Sobek taught me second entry. I'll just bring that right back up here and delete the 1 and type in 80 over top of what we had there. And that's not too cumbersome either. But what if you had a lot of problems, dozens of conversions to do, or any time you saw the thermometer, you wanted to convert that. You were in a country that uses Celsius, and you were always converting. Then there's a faster way to do those conversions. What we would do is first of all hit this y equal 2 key, and under y sub 1, we're going to type in parentheses 9/5, close the parenthesis, and we're going to use the variable x plus 32. Okay, and we're going to use a feature called the table feature. Now the table feature has two operating modes, and for this application we're going to change that mode so that we can type in any value that we want. So we only have to do this once. Hit the second. Here's table set right up here above the window button. And you can see that the independent variable is currently in automatically being calculated for you. Okay, it's starting at a 0 and incrementing by 1. And we could change that and so forth. And we could decrement if we want to. But we're going to just move our arrow, use our arrows to get down to here. Hit the right arrow key to highlight ask. And in the ask mode, then you could type in any value you want for x, which is your Celsius temperature, and it will convert that for you. So we've changed that into the ask mode. Second quit, we're back at the home screen again. And now to get into the table is right above the graph button. Okay. Oh, by the way, all these graphing buttons, we have other videos for showing you how to graph. Of course, with a graphing calculator, it's one of the most powerful features that it has, and don't be disappointed when I don't get to it today. I'm not. This is not the purpose of this lesson. But I do want to show you tables. So second table, and here we could type in any value we want. So 100 degrees would be 212. Let's see. 0 degrees, we know that would be 32 degrees in Fahrenheit temperature. 56 degrees Celsius would be 132 degrees Fahrenheit. So any value you want to convert, 15 degrees Celsius, 59 Fahrenheit. It's like rapid fire machine gun evaluation of the expression with any value that you designate here in the first column. So the table is a pretty neat feature, for rapid fire substitution and evaluation, and so I thought you would like that. All right, so that's the table feature. Let's move on. The last topic I wanted to cover in this introductory video lesson is how to store values into variables locations. Sometimes you'll do a real monstrous calculation, and when you evaluate it, you know that you're going to need this number later down the road, so you get out your pencil and pen and you write that down, because later on you're going to have to use that again. Well, you don't have to write it down. You could just store it someplace and get it back anytime you want. Your calculator has 26 storage locations, one for every letter of the alphabet. And so, for example, if we want to take a 5 and store it into memory location X, we could just hit 5. And this STO button here, that's store. Hit that one time, and a right arrow appears, meaning store, and it's waiting for where do you want to store this. And the easiest place is X, so you could hit this X button, hit the Enter key, and now a 5 is stored into that variable X. So later, if you had some expression, you know, like 6x, it knows that x is a 5. It'll take 6 times 5 and give you 30, see? And then you could turn your calculator off and pick it up the next day and then type in x plus 4, and it will remember that that is a 5. 5 plus 4 is 9. And evaluate that, you'll get 9 until you store something else there. If you want to store in one of the other letters of the alphabet, okay, X was easy. We had a special button just for X. But if you wanted to store something in A, well, let's just say, for example, we want to take a 2 and store it in A. 2 stored into alpha A. And then we'll take 3 and we'll store that into alpha B. And then we'll take 4 and we'll store that into alpha C. All right. Now, if I were to type in alpha A plus alpha B plus alpha C, what do you... I was just going to say, what do you think we're going to get? All right. Were you thinking 9? You're a pretty quick thinker. All right. Didn't mean to hit the Enter key that fast, but 2 plus 3 is 5, and 5 plus 4 is 9. Yes, it remembers that this is a 2 plus a 3 plus a 4, and this particular feature of storing values it's not just a luxury as it is in the application that I was describing, but when we get into programming, that would be my video lesson 7 and video lesson 8, it's mandatory. Okay, we need memory variables to store values and recall them when we want them. So although we introduce it here, it's going to become most beneficial when we're programming with the TI-84 calculator. The TI-84 calculator is more than just a graphing calculator, meaning it does statistics. It's a matrix calculator. It's programmable, and it's just so powerful. And most people who own, many people who own these TI-84s never even tap into the rich resources that are available to them, and they're just unaware of what it all can do. But you can be aware. I have a lot of more video lessons. They're all going to be they're all available at the website www.amysflashcards.com, and you can go there and access any one of those videos, and I think you'll be glad you did. I hope you enjoyed this lesson, and if you have any comments or suggestions for other lessons you'd like to see, I have my email address in this section down here below here, info@amysflashcards.com, and I'll be glad to hear from you. So feel free to fire me an email. Thanks for joining me today with just a basic introduction to basic features of a TI-84 calculator.